नमस्कार साथियों, आप सभी का स्वागत है इस समय के आई वंडर के वेबिनार में। जो साथी हमें हाल ही में जुड़े हुए हैं, उनके लिए एक नया जो इशू हमारा आया है आई वंडर का, उसके ग्लिम्स हम लोग इस वेबिनार के शुरुआत में देखते हैं और फिर हम हमारी चर्चा शुरू करेंगे।
A middle school science teacher? Then this magazine is for you. I Wonder is a science magazine for middle school teachers published twice a year by Azim Premji University. In its latest issue, find out how the daytime sky can be an astronomy lab that your students explore with equipment they construct themselves from inexpensive materials. How empathy towards his patients allowed one of the world's most celebrated neurologists to see connections between modern medicine and questions of social significance. How science teachers have used their classrooms to empower students from marginalized backgrounds and low-resource schools with the skills and confidence to meet real-world challenges. How observing the features of a flower can help your students predict its most likely pollinators. How teaching science as a process of discovery is different from teaching it as a collection of facts. Why we do not have a cure for colds and how students can protect themselves and others from catching this most common of infections. A book with ideas for 365 fun experiments that can bring science from labs and textbooks into the everyday worlds of your students. Ideas you could use for classroom demonstrations to help your students test and understand the connections between force and motion more accurately. And how the saltiness of the sea is related to volcanoes, hot springs, and rainwater. That's not all. This issue also contains ideas for many simple and exciting activities that you can carry out with your students. Plus, some teacher's guides to help you include the ideas in this issue in your lesson plans. Download the issue for free. Subscribe to us if you would like a free print copy for your school or library. The magazine is available in English, Hindi, and Kannada.
तो साथियों, आपने अभी देखा एक वीडियो जो रिसेंट इशू जो है आई वंडर का, उसके बारे में एक जानकारी दे रहा है। मैं आप सभी का फिर से स्वागत करता हूं आई वंडर के इस वेबिनार में। मेरा नाम है अमोल और मैं अजीम प्रेमजी फाउंडेशन में एज अ टीचर एजुकेटर सिरोही राजस्थान में काम कर रहा हूं। मेरे साथ आज जुड़े चर्चा करने के लिए आनंद, और हम उन्हीं के द्वारा लिखे गए एक आर्टिकल के ऊपर हम लोग चर्चा करेंगे। तो स्वागत है आनंद। थोड़ा आई वंडर के बारे में, हाँ, थोड़ा आई वंडर के बारे में फिर से एक मैं छोटी सी जानकारी में देना चाहूँगा। जैसा जो दर्शक पहले से जुड़े हैं आई वंडर से और जो नए नए से जुड़े हुए हैं, आई वंडर जो है एक साइंस मैगजीन है जो खास करके साइंस टीचर, साइंस एजुकेटर्स के लिए लिखी जाती है, ताकि कक्षा में विज्ञान पढ़ने पढ़ाने के जो नए तरीके हैं, नए नवाचार है, उसके बारे में जानकारी मिले और उस ऐसे आलेखों से हम लोग भी रूबरू हों। हम आई वंडर में शिक्षकों द्वारा, टीचर एजुकेटर्स द्वारा लिखे गए लेखों को भी स्वीकार करते हैं। आप आपकी आइडिया 100 वर्ड्स में लिख के हमें भेज सकते हैं, और हमारा जो एड्रेस है, ईमेल है, वो है iwonder@apu.edu.in। तो आप आपके आइडियाज, आपकी जो संकल्पनाएं हैं, आपकी जो इंटरेस्ट है, उसको लिख के हमें, हमारी टीम को भेज सकते हैं। आई वंडर वेबिनार को लेके अगर हम बात करें तो साल भर में आई वंडर के 6 वेबिनार हम आयोजित करते हैं, जिसमें कि पुराने लेखों से, पुराने इश्यूज से जो लेख होते हैं उसके ऊपर हम चर्चा करते हैं। वो जो लेख जिन लेखकों द्वारा लिखे गए हैं, उनके साथ ये चर्चा आयोजित की जाती है, ताकि उन लेखों को लेके उन लेखकों की जो आइडियाज है, जो कंसेप्ट है, उसको लेकर और बातचीत हो पाए। अगर आई वंडर वेबिनार को अगर आप रेगुलरली इसके बारे में अपडेट जानना चाहते हैं, तो आप हमारे चैनल को अजीम प्रेमजी यूनिवर्सिटी पे जो ये प्रसारित होता है, उसे आप सब्सक्राइब कर सकते हैं, ताकि अपडेट्स आपके पास आते रहेंगे। आज की चर्चा हम लोग जो करने वाले हैं, आई वंडर में आनंद द्वारा जो लेख लिखा गया था, फ्लैट अर्थ, ये लेख लिखा गया था दिसंबर 2022 के इशू में, जो कि अंग्रेजी में प्रकाशित हुई थी। और यही लेख अक्टूबर 2023 में इस इशू का हिंदी संस्करण जो आया था, उसमें ये चपटी धरती के नाम से लिखा गया है। तो इस आर्टिकल को लेके हम आज आनंद से चर्चा करेंगे। तो आनंद, फिर से आपका स्वागत करता हूं। आपका थोड़ा एक इंट्रोडक्शन में हमारे दर्शकों को देना चाहूंगा। आनंद जो है इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस एंड टेक्नोलॉजी में एस्ट्रोफिजिक्स पढ़ाते हैं, और इन्हें एस्ट्रोनॉमी से काफी लगाव है, और इसीलिए ये अपने क्लासरूम तक ही सीमित नहीं रहते। ये इस विषय के अलग अलग जो अवधारणा है उसके ऊपर बातचीत करने के लिए स्कूल कॉलेजेस में जाके जो स्टूडेंट्स हैं उनके साथ बातचीत भी करते हैं। ये पब्लिक लेक्चर्स में भी जाते हैं, जहाँ पर ये लोगों के साथ भी चर्चाएं करते हैं। इसके साथ साथ आनंद जो है, इन्होंने कुछ ऑल इंडिया रेडियो पर एस्ट्रोनॉमी से रिलेटेड कुछ रेडियो प्रोग्राम्स भी बनाए हैं, और इनकी एक डॉक्यूमेंट्री भी बनाई है इन्होंने, जो यूट्यूब पे आप देख सकते हैं, हिस्ट्री ऑफ एस्ट्रोनॉमी। तो आनंद, आपका स्वागत है।
Thank you, Amol. Thank you for the introduction. And hello to all the people who have logged into this webinar.
तो आज हम दोनों इस लेख पर जो चर्चा करेंगे, हमारी बातचीत जो होगी वो हिंदी में होगी और अंग्रेजी में होगी, क्योंकि हमारे जो पाठक है, जो हमारे जो दर्शक है और पाठक है, ये काफी मतलब भारत में काफी सारी जगहों से आते हैं। जैसे मैंने कहा कि आई वंडर जो है ये अंग्रेजी के साथ साथ हिंदी और कन्नड़ा में भी प्रकाशित होती है। तो इन राज्यों के और इन भाषाओं को जिन बेल्ट में बोला जाता है, वहां से ये पाठक और दर्शक हमारे साथ जुड़े हुए हैं। तो इसलिए हम ये जो वेबिनार है इसको हम थोड़ा मिक्स लैंग्वेज में करेंगे। तो आनंद, हम लोग बातचीत शुरू करते हैं। आपने जो ये लेख लिखा है, ये काफी बेहतरीन लेख है, और ये बातचीत करता है कि कैसे हम बच्चों के साथ इस आइडिया पे बात करें कि धरती का आकार कैसे है। जैसे कि हम लोग जानते हैं कि हमारे आसपास कई सारी चीजें हम लोग देखते हैं। साइंस में हम लोग जो बात करते हैं, हमारे आसपास की चीजों से ये जुड़ा हुआ होता है, और ये जो चीजें होती हैं, ये क्यूरियोसिटी हमारे मन में क्रिएट करती है। उसी में एक है कि हम जिस धरती पर रहते हैं, उन्हीं सवालों में एक सवाल ये भी आता है कि हम जिस धरती पर रहते हैं उसका आकार कैसा है। और आपने भी इस लेख में इसी को लेके चर्चा करी है। तो आप थोड़ा मुझे बताएंगे कि ये धरती का आकार जो जानना है, इसके क्या प्रैक्टिकल इम्प्लीकेशंस हो सकते हैं, किसी मतलब बच्चे के लिए या सामान्य व्यक्ति के लिए भी, एक टीचर के लिए या सामान्य व्यक्ति के लिए भी। जियोग्राफर और एस्ट्रोनॉमर तो इसको लेके काफी चिंतित रहे ही है, लेकिन अगर हम बात करें इस ग्रुप की, तो इनके लिए आप इस विषय को कैसे देखते हैं?
Right. Okay. So that's a great question. In the outset, let me apologize that my responses are going to be in English, not in Hindi, because I'm not very fluent in Hindi. So in the interest of keeping my answers relevant, I will speak in English. So that's a great question. So why is it important for school students, school teachers, or for that matter, a common person to worry about the shape of the earth? And I think I can think of a few different reasons. One of the major motivations for education is to raise our own awareness about the world that we are living in. Okay, so that has to be one of the main drivers of education, whether you are a teacher or whether you are a student who is sitting in a classroom. So we generally call this a raising of awareness about the world we live in as scientific literacy. That's the term that we use. So understanding the shape of the earth is part of that basic scientific literacy. Knowing the earth shape, it also ties into some kind of critical thinking and ability to distinguish scientific facts from misinformation and our immediate perception. For example, as this article, the reason why I wrote this article is because in our day-to-day existence, it's not very evident to us that we are living on an earth that is not flat. In fact, our everyday perception at least tells us very casually, if you look at the world around us, it gives us this feeling that we are living on a flat earth. So it's important to understand why what we perceive with our senses, what it may not be a complete description of the reality. So it ties in therefore with critical thinking. And so in a world where there's a lot of information, some of it is incorrect, understanding fundamental concepts like this will help us to evaluate what is true and what's not. For example, if we do not know that the earth is, suppose we don't pay attention to the fact that what is the true shape of the earth, whether the earth is flat or sphere, if you do not know that, then the shape of the earth affects how sunlight reaches different parts of the planet, which in turn influences weather patterns and seasons. Okay, so if you want to understand seasons, then you cannot understand it with the idea of a flat earth. You have to invoke the idea of a spherical earth. So the idea of flat, what the true shape of the earth is, that is tied in with other knowledge that we may be interested in also, even if we may not be interested in the true shape of the earth. And also, I mean, another example is we know that there are two different time zones on earth. So why are there different time zones? So when it is a daytime in India, it is night in North America. Why is that? We may learn that in class. So in order for us to make sense of that information, it's important to know why the earth is, what the true shape of the earth is. Why when it is summer in one hemisphere, it is winter in another hemisphere. How weather systems move across the globe. So in short, what I'm trying to say here is that if you ask me what is the relevance of this knowledge of earth shape connects itself with a broader knowledge about our planet, about our space, and how various natural systems work within, around us. So this is kind of like the foundation on which many of the other ideas are built. And therefore, that makes it very practical. So even if we may not be, even if we are not that interested in this particular question itself, but unless we understand this question and its answer, we may not be able to build upon this with further knowledge. So I think that's one reason why somebody who is in school, somebody who is teaching, should be concerned about this particular question. Okay. So which makes me maybe ask you a question. I know since this article has come out some time back, and there has been a chance for people like you to probably use this article in a classroom context. So maybe you have already used it. So I just wanted to ask you, Amol, how do you see this knowledge that is described in this article about the true shape of the earth? How do you see it connecting with a child's world? For example, you just mentioned that right now you are primarily working in a rural area in Rajasthan. So in that rural context especially, are there certain aspects of this particular article, when you apply it to children in middle school or even lower grades, do you see any challenges associated with it? Do you find that the children are naturally curious about the shape of the earth? Are they asking questions in that direction? What has been your experience?
तो आनंद, ये काफी मजेदार एक्सपीरियंस रहता है इसमें, है ना। जैसे आप भी बच्चों के साथ बातचीत करते हैं स्कूल में, है ना। खासकर आप जहाँ पे ये पढ़ाते हैं तिरुवनंतपुरम में आप काम करते हैं, और वहाँ पर केरल में भी आपने कई सारे बच्चों के साथ बातचीत करी है, तो आपके एक्सपीरियंस में भी ये चीज़ें रही हुई है। मुझे लगता है कि जिस रिमोट लोकेशंस की या दूर दराज के इलाकों की हम लोग बात करते हैं हिंदुस्तान में, वहाँ पे थोड़ा एक्सपीरियंस अलग हो जाता है। यूजुअली बच्चे पूछते ही नहीं है कि धरती का आकार कैसा है। तो मैं ये देखता हूँ ना कि शहर के बच्चों के पास कुछ तो आइडिया होती है इन चीज़ों को लेके कि वो स्कूल में ग्लोब होता है उसको देखते हैं, कई जगह पे टीचर्स थोड़ा मोटिवेट भी करते हैं या बच्चे सुनते भी है कई सारी चीज़ें, देखते भी है, तो उन्हें एक अंदाजा होता है कि धरती गोल है। लेकिन वहां पर भी वो इसलिए उसको नहीं पूछते कि उनको तो पता ही है कि भाई धरती तो गोल ही है, अब इसमें क्या पूछेंगे। दूसरा एक है कि जिस तरीके से टॉपिक को इंट्रोड्यूस किया जाता है उसमें स्कूल में साइंस के करिकुलम में, तो उसके ऊपर कभी बातचीत होती नहीं है कभी, मतलब कि धरती का आकार कैसा है इसको लेके बच्चे क्वेश्चन करें, इसके कोई वो नहीं है, मौके नहीं है, अपॉर्चुनिटीज नहीं है। तो मैंने देखा है कि कई जगहों पर ये बच्चों के मतलब कंसिडर कर लेते कि ये गोल ही है, और रूरल एरियाज में बच्चों को ये मौके या इस तरीके के बातचीत का एक्सपोजर अमूमन नहीं होता है और उनसे बातचीत भी नहीं होती, तो इसलिए वो सवाल ही नहीं पूछते। तो ये थोड़े दो तरीके के एक्सपीरियंसेस मुझे हुए हैं। आप भी अगर उसमें देखेंगे, आप भी आपका एक्सपीरियंस शेयर कर सकते हैं कि आप जब इन चीज़ों को लेके बातचीत करते हैं बच्चों के साथ, तो आपके भी क्या अनुभव रहे हैं। कुछ चीज़ें हम लोग बातचीत में आगे भी बात करेंगे, लेकिन एक आप रिस्पॉन्स करने से पहले बस एक मैं चीज़ बताना चाहूँगा कि जो दर्शक, जो पाठक हमारे साथ जुड़े हुए हैं, आनंद और मैं तो बात कर ही रहे एक दूसरे के साथ, हम भी आप भी हमें सवाल पूछ सकते हैं। आपके जो सवाल है आप चैट बॉक्स में हमें, हम दोनों को पूछ सकते हैं कि भाई आपके कुछ अगर इस तरीके के एक्सपीरियंस या कुछ आपके सवाल होंगे आर्टिकल को लेके तो आप पूछ सकते हैं। तो आनंद, आप भी बता सकते हैं कि जब आप बच्चों के साथ या इवन कॉमन पब्लिक के साथ आप जब बात करते हैं टॉक में, तो आपके भी कुछ इस तरीके के एक्सपीरियंसेस होते हैं क्या?
Yeah, so true. So when we interact with children, sometimes, often what happens is they take many of this information for granted. For example, they all know that Earth is a globe. Okay, so if I ask what is the shape of the Earth, they will say it's a globe, it's a sphere, etc. But if I follow it up with a question of how do we know this? Okay, then they are thinking. Okay, they are thinking. Okay, how did I first come to know that Earth is? Then they'll say that probably in class we learned it. So, in other words, what they are saying is that they have heard from somebody else that the Earth is round, and in many places there is as you rightly said, in a classroom, in a school, a globe is there. But we also have a map also is also sometimes displayed where the entire Earth is shown as flat. But then they are told that that's not the true shape. The globe is the sphere is the true shape of the Earth. So this is all information that has been told to them. But as a scientific fact, if you ask them, okay, can we figure out how this information was acquired for the very first time? That is what when they usually they start thinking about it. And so I think I have not really in my interaction with the school children, I don't remember that anyone has directly asked how do we know that Earth is not flat, etc. But that is also partly because right from a very young age they have been told that Earth is a sphere, so they have never probably thought, okay, is that how I am experiencing Earth? I mean, living on Earth, is that how I see it? So somehow that information has sunk in, and they have stopped forgetting about. They've kind of forgotten about how that information has come. Yeah.
तो ये सही बात कही आपने कि भाई ये मतलब ये टेकन फॉर ग्रांटेड लिया था कि अर्थ का शेप ऐसा ही होगा। मेरी कुछ शिक्षकों से भी बात हो रही थी, जब हम लोग इस विषय को लेके बात करते हैं शिक्षकों के साथ, तो उनके भी अनुभव मजेदार होते हैं। कुछ शिक्षक ये चाहते हैं कि बच्चे थोड़ा इस विषय पे या इस टॉपिक के ऊपर बात करें, तो कुछ मजेदार चीजें भी बच्चों की आती है, जैसे कि आपको कैसे पता है कि धरती गोल है? तो यूजुअली ये कहावत है ना कि भाई दो लोग धरती गोल है तो कहीं ना कहीं मिल ही जाएंगे, मतलब एक दूसरे से जब मिलते हैं तब ऐसे कहते हैं ना हम लोग, अरे धरती तो गोल है। मतलब हो सकता है कि ये भी बात जो है, ये धरती गोल हो जाने के बाद ये कहावत आई हो, ये मुहावरा आया हो, लेकिन धरती तो गोल है, हम तो मिल ही जाएंगे। तो इसीलिए तो ये बातचीत में आता है, और ग्लोब भी होता है क्लासरूम में। तो कुछ टीचर्स मेरे एक्सपीरियंस में है ये भी कि थोड़ा प्रोवोक करते हैं कि भाई ठीक है कि धरती गोल है, तो हम कहाँ रहते हैं। तो बच्चों का ये जवाब होता है कि हम धरती के मतलब उस गोल ग्लोब के अंदर रहते हैं। तो इस तरीके के कुछ अल्टरनेट कंसेप्ट हम कह सकते हैं। इसको 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 लेके लेकिन बातचीत की जरूरत होती है, और शिक्षकों का भी ये मानना है, और मेरे भी अनुभव में ये चीजें रही है कि जब तक बच्चों के साथ बातचीत नहीं करेंगे तब तक इस विषय पे मतलब समझ बन पाना मुश्किल है। आपने जैसे एक अच्छा रिस्पॉन्स आपने इसमें एक दिया कि भाई अगर अर्थ का शेप हमें समझना क्यों है, क्योंकि एक तो हमारे आसपास के जो होने वाले अनुभव है उसको हम लोग ठीक तरीके से समझे, जैसे आपने सीजन का भी एग्जाम्पल लिया, और टाइम जोन का भी आपने एक एग्जाम्पल उसमें लिया कि भाई अगर इन चीज़ों को समझना है तो अर्थ की शेप जो राउंड है, स्पेरिकल है, उसको हमको समझना पड़ेगा। लेकिन कई शिक्षक ये सवाल पूछते हैं कि ये एक जो विषय है, मतलब एक एक जिस तरीके की ये कंसेप्ट है कि धरती का आकार क्या है, क्योंकि अमूमन धरती का आकार दिखता नहीं है, तो ये इसके ऊपर बातचीत कैसे करें हम लोग बच्चों के साथ। आपने आर्टिकल में कुछ चीजें इसको लेके लिखी हुई है, थोड़ा इसको आप अगर हाईलाइट करेंगे कि इसको समझे कैसे हम लोग, है ना, तो कुछ थोड़ा और समझ में आए।
Right. So I think first let me try to address this question of why we should learn about it. Because as you said, sometimes we may wonder, this is a known information. This is a known fact. We can just tell the students that the Earth is sphere. We can show satellite pictures. We can we can take a globe to the class and show that it is Earth is not flat. So why should we spend time? Why should we spend our effort trying to rediscover this established knowledge? Okay. In a sense, we are trying to rediscover this knowledge. Is there any advantage or is there any merit in that? And I think there is a lot of merit in it because, especially when you are teaching such topics to a very young group of students, small children, and new learners. See, learning science, in some sense, it means not just learning about the subject of science, the information that is contained in science, but also the process of science and the methods of science. So the process by which science operates, observations, inference, and relying on existing knowledge. So this is what generally, this is how science operates. It relies on direct observations, but it doesn't take those observations at face value. Then there is a deep thinking that goes in on what is the best possible way to interpret those observations. And then when you're interpreting those observations, you rely on existing knowledge. So in our Indian vocabulary, we say it's pratyaksha, anumana, and agama, right? So you have observations, you have inference, and then agama is the body of knowledge that is already existing. So when you bring this topic up on, okay, we all know that the Earth is not flat, but can we discuss this topic in class and see how do we know that the Earth is not flat? When children are given that opportunity to rediscover that concept, they are going to engage in critical thinking. Instead of passively receiving information, it gives them an opportunity to question, explore, and reason, which enhances their analytical skills. Okay? So, in that sense, there is some merit to it, and that rediscovery of any information, when they discover it for themselves on how we can figure out what is the true shape of the Earth, or how we can rule out the possibility that it is flat. When they rediscover it, that leads to a much deeper understanding of the concept. So when they are uncovering this knowledge by themselves, they are more likely to grasp the underlying principles and remember them for a very long time, as opposed to simply memorizing those facts. So in other words, they are approaching learning in a way that makes sense to them. So this is, and I think that's really, I think one of the reasons why, even if there is a fact that is very fundamental and which is already known to everyone, it's important to maybe go through that process of churning, that process of discussion, that process of rediscovery. And one more reason why I think it's important, and then I will come answer the question that you had asked. One more reason why I think it's important to engage in this discussion is because, as we had earlier mentioned, it helps children to appreciate the fact that whatever they are learning has come about from generations of human effort to make sense of the world around. It's a collective wisdom of generations that they are inheriting. For example, this fact that the earth is round, we often take this knowledge for granted. So, which means that it makes us sometimes regard existing knowledge as simple or trivial, or sometimes even boring. If you tell children that the earth is sphere, they'll say, yeah, we know that, and what is the new information there? So, it would seem like knowledge that is ordinary. But for a moment in the classroom, if we say that for a moment you forget that this information is known to us, what experiments or observations would you do to conclude that earth is not flat, or that the earth is spinning, for example? I mean, there is no our direct perception doesn't give us any impression that the earth is rotating or it is going around the sun. So these things are there in the text books. We learn it as an information, but we may not have internalized it. So if you are living 1,000 years back in time, you do not know any of this information, right? So how close to the truth can we get with observations and pure thought? So that exercise or that idea can be brought into the classroom by rediscovering or reinvestigating some of these known facts. So that is one thing which I wanted to put across. And then the other thing is, you were asking how do we discuss, how do we explain to the children what the true shape of the earth is. So that's where I think the relevance of this article comes in. In the article, I have tried to put together some simple observations, some simple experiments that can be done with minimal equipments, very simple equipments, not any costly apparatus, that can be used to demonstrate that there are things that you can gather from everyday life, which clearly tells us that the earth is not flat and it has a curvature to it. Now, from there, going to the actual shape of the earth is a little bit more difficult, and that would require a little bit more thinking, but at least we can rule out the possibility that what we experience directly as a flat earth is not the reality. So those ideas are precisely what is being dealt with in this article.
तो आनंद, ये सही बात है कि इस बात को जानने के लिए काफी बड़ा एक पर्सपेक्टिव भी चाहिए, इस चीज को समझने के लिए भी, लेकिन एक क्यूरियोसिटी बच्चों के मन में किस तरीके से हम लोग इग्नाइट कर सकते हैं इस टॉपिक को लेके, कि जैसे मैंने पहले भी कहा कि जिस तरीके से साइंस में ये मतलब साइंस और ज्योग्राफी में ये चीजें करी जाती, देखेंगे कि एस्ट्रोनॉमी से जुड़े हुए जो एस्ट्रोनॉमी और ज्योग्राफी में जो जुड़े हुए कंसेप्ट है, साइंस में और ज्योग्राफी में इसके जो चैप्टर्स आते हैं, 5th क्लास में एनसीईआरटी की मैं अगर बात करूं तो सौर मंडल का चैप्टर आता है, सोलर सिस्टम का। वहां पर भी ग्रहों के आकार एक गोलेम के रूप में दिखाई दे, मतलब दिया रहता है कि ये डायग्राम गोले के रूप में। फिर 6th क्लास में एनसीईआरटी के अगर हम ज्योग्राफी की किताब देखें तो उसमें सीधा सीधा अर्थ करके एक चैप्टर है, जिसमें कि वो सीधा ही शुरू होता है कि भाई हमारी जो धरती है उसका आकार गोल है। 8th क्लास में पहले एक चैप्टर था, अभी वो निकल गया है, आवर यूनिवर्स, उसमें भी ज़्यादा इस बात को लेके चर्चा होती नहीं है। तो शिक्षकों का एक मतलब सवाल रहता है कि भाई ऐसी कंसेप्ट्स के ऊपर जब बात करते हैं तो वो प्रमाण कैसे हम लोग, या उस विषय तक पहुंचे भी कैसे, जैसे आपने भी कहा ना कि साइंस में जो पुराना जो एक हमारे भारत का भी एक अप्रोच रहा है भारत में, प्रत्यक्ष प्रमाण आगमा, तो ये प्रमाण तो दिखता है कि भाई धरती तो दूर दूर तक फ्लैट ही दिखती है। तो जैसे आपने भी कहा कि ये जो विषय है ये थोड़ा सा कंसिडर भी किया जाता है, हमको तो पता ही है कि धरती का आकार गोल है, लेकिन वो शुरुआत कहाँ करें बच्चों के मन में वो क्यूरियोसिटी जगाने की। इवन साइंस में ही एक चैलेंज होता है टीचर के सामने कि जो चीज़ों को मान लिया जाता है कि भाई ये ऐसी है, तो उसके लिए क्यूरियोसिटी कैसे क्रिएट करें, क्या वो एफर्ट रहने चाहिए?
So yeah, so that's a great question. See, probably teachers who are listening to this would have more experience in answering this question because they are the ones who are dealing every day with children. But let me share a few of my own thoughts that might work on certain occasions. So, in general, how do you impart a certain curiosity in children towards science, and how do you keep that curiosity alive? In science, obviously, the best way to engage in the teaching and learning of science is to bring in hands-on experiences. So that is one thing that children really like, and engage children with hands-on activities that allow them to explore and experiment. So science experiments, building models, etc. These are all activities that simulate curiosity through direct interaction. And so this is a tried and tested approach. So I think in this article also, therefore, all the reasonings that we have given on how to prove that the Earth is not flat are all based on hands-on experiments. And the second thing is to raise curiosity and to sustain that curiosity about this topic or in science in general is, I would say that children have to see that what they are learning in school connects with the world around them. I think that was the spirit of your first question also. I mean, why is it relevant for school children or teachers? So they have to see the connection with the world around them. So whether it's explaining how chemistry and physics and mathematics works, if you can connect with something that is relevant to their life. For example, what is chemistry's role in cooking? What is physics or mathematics role in while playing sports? So if you make those real world connections, that helps them see the relevance of what they are learning. So connections and examples that they can relate to in their everyday life. And so that, I think, is another way to sustain curiosity. And the third thing, I think, is that we have to, if we are going to teach science in a very engaging way, we have to learn to celebrate mistakes. Okay, so we have to somehow teach children that mistakes in thinking and in arriving at conclusions are very much a part of learning process. And this article is the spirit of this article is also that our direct perception leads us to a conclusion that is completely wrong. But it's okay to be wrong. Okay, there was a time in the history of humankind when vast majority of the people thought exactly what we are thinking, that the Earth looks flat, therefore it has to be flat. So it's therefore we have to learn to accept that there can be mistakes. So encourage these children to take risks, try new things, and learn from mistakes and failures. So what this does is this helps them develop a growth mindset, where they will see such kind of challenges or such kind of intellectual challenges as opportunities to learn rather than as obstacles. So somehow, that aspect is also very, very important. So in the process of learning, if we find that the child is making a mistake, then we have to see whether that mistake is because of incomplete understanding or the mistake is because of carelessness. One has to differentiate these two. And if it is because of incomplete understanding or the way the child is thinking, then that's not really a mistake. And that is very much part of the learning process. And lastly, I would say, how do you keep curiosity alive? I think children tend to emulate adults. So if we as teachers or if we as parents show a high level of enthusiasm and curiosity towards these things, children are also likely to do that. So when children see that adults are being very curious and excited about discussing such topics, they are also more likely to adopt the same attitude. So I think that those are probably the what I would think, those ways to keep raise the curiosity levels of children and maybe also sustain it. Yeah, so that's what I wanted to share.
तो आनंद, आपने काफी अच्छी बात कही कि अगर हम बातचीत नहीं करेंगे इन चीजों को लेके तो कई तरह की मिसकंसेप्शंस भी डेवलप होती है, और चीजों के ऊपर सवाल उठाना, उसके बारे में प्रश्न पूछना, ये एक साइंस का तरीका है जिसको हमें मोटिवेट भी करना चाहिए। ये मुझे लगता है ये भी एक क्यूरियोसिटी जनरेट करने के लिए आपको मदद करेगा कि बच्चों के जो सवाल है उसको आप कितना तवज्जो दे रहे हैं, कितनी उनको उनकी तरफ ध्यान दे रहे हैं और उनको मोटिवेट कर रहे हैं पूछने के लिए। सिर्फ घर पर ही नहीं, क्लासरूम में भी मुझे लगता है कि कई टीचर्स का ये मानना है कि अगर बच्चों के सवालों को अगर हम रिस्पॉन्स करते हैं, मतलब उन्हें मोटिवेट करते हैं, तो बच्चे जो है ज़्यादा सवाल पूछने के लिए उत्सुक भी होते हैं।
Correct.
तो ये भी एक मुझे लगता है क्यूरियोसिटी क्रिएट करेगा ही, और खुद भी अगर हम दिखाएंगे इन चीज़ों में क्यूरियसनेस, तो आई थिंक आपने जो लास्ट में कहा कि बच्चे जो है वो भी इस तरफ बढ़ सकते हैं। तो आनंद, फिर से एक आर्टिकल की तरफ आते हैं आपके। जैसे आपने भी कहा अभी कि बहुत सारे समय तक लोग ये मानते थे कि धरती गोल नहीं चपटी है, और ये बहुत बड़ा एक वर्क था फिलोसोफर्स का इसको मानने के लिए। लेकिन इसमें भी कुछ जो एक फिलोसोफर्स थे, वैज्ञानिक थे उस समय के, उन्होंने इस निष्कर्ष तक पहुंचे कि भाई हमारी धरती गोल नहीं, सॉरी, हमारी धरती चपटी नहीं, गोल है। तो दो वैज्ञानिकों का आपने उल्लेख इसमें किया है, आर्यभट्ट जो कि हिंदुस्तान के हैं, और दूसरे इराटोस्थोनिस। तो आप थोड़ा बताएंगे कि ये इस कंक्लूजन तक कैसे पहुंचे थे?
Right. So in the article, in the box material of the article, I mention about these two people. One is Aryabhatta and the other is Eratosthenes. So let's talk about Aryabhatta. So Aryabhatta wrote this seminal text in mathematics called Aryabhattiyam, and this was written in 499 CE, which means almost 1525 years ago. This text was written. And this text has 121 verses divided into different segments. And one of the segments is called Golapada, which is a segment that deals with spherical astronomy. And in that portion, Aryabhatta states several interesting facts about the Earth. He says that the Earth stands suspended in space. And he mentions that we are surrounded by stars and planets. And he also explains that the Earth's shadow on the moon during an eclipse, he explains that the eclipse is because the Earth is casting a shadow on the moon. That is the cause of lunar eclipse. And then he says that the Earth's shadow on the moon during a lunar eclipse is circular, which supports the idea that the Earth is not flat. It could be a sphere. So the observation that he relies on is, one of the observations is that he is carefully looking at how eclipses are happening. Lunar eclipses are happening when Earth comes between sun and the moon, and Earth's shadow appears on the moon. So he sees that if the Earth were flat, then that's not how the lunar eclipse would unfold. So this is the idea that he takes on. And Aryabhatta also talks about not just the spherical shape of the Earth, but he also says that this Earth is spinning in its axis, the Swayambhramanam, or the axial rotation of the Earth. He talks about that. He reasons, how does he arrive at that conclusion that the Earth is rotating? As I mentioned earlier, just like flat Earth, our direct perception, our immediate perception does not give us any indication that we are on a spinning Earth. or that it is revolving around the sun. So it's very difficult, if you do not know that information, it's very difficult to arrive at that conclusion. So the way Aryabhatta arrives at this axial rotation of the earth, or how he reasons it is that he says that objects in the sky, we see them rising in the east and setting in the west. This is true for the sun. This is also true for the planets, the stars, everything. They all rise in the east and sets in the west. And then he brings out this metaphor of a person who is sailing in a boat. So he says that when the person sailing in a boat is moving in one direction, everything that is on either side of the shores, they will move in the opposite direction. So he's invoking the concept of relative motion there. So this fact about Earth spin, which may seem very obvious to us now, he acquired it through this careful observation and insight. And he also says that if you look at objects rising and setting, everything that is rising in the east at the same time, they set in the west at the same time. In other words, things that are rising together, they set together. Stars that are rising together, they set in the west at the same time. So this could mean one of two things. One is that either those stars are moving with the same speed, or that we are spinning and the stars are stationary. And obviously he goes for the easier explanation, which is that we are spinning. So all these facts are mentioned there. Now, one problem with these ancient texts, whether it is Aryabhatiyam or Brahmasputa Siddhanta or any of those texts, is that they are written in a very terse, concise form. And often they don't give elaborate descriptions of how that knowledge was arrived at. One possible reason is because writing was a luxury at that point of time. It was not possible to write a 1,000-page manuscript. It's much more easier to write a 10-page manuscript. So people would have written these shorter texts because the people who used to read those texts were also familiar with this knowledge. So there was no need to explain it. And often bhashyas or commentaries to these texts is where we find explanations on how this knowledge was arrived at. So to summarize whatever I just said now, in Aryabhatiyam there is mention about the fact that Earth is not flat, it could be a sphere, and there is also the fact that the sphere is spinning, this is rotating, there is an axial rotation to the Earth. So this information was arrived at by looking at eclipses and by looking at distant stars. Now the other is this Greek mathematician and astronomer Eratosthenes. He is very widely known because of the fact that he was one of the first persons to calculate the Earth's circumference with good accuracy. And he also talks about, in that process, he also talks about the fact that Earth is not flat. Strong evidence that Earth is not flat, but it's a sphere. Now, how Eratosthenes did this, I think it's mentioned in the article. He used a very simple method where he looked at the shadow cast by an object in two different locations in Egypt. One was a place called Syene, which is the modern day Aswan in Egypt, and the other is Alexandria. So these are two different places separated by a distance. And he found out that on any given day at any particular time, two objects which are roughly of the same height, they cast very different length shadows. Now, if you think of the Earth as a flat surface, then we expect that objects should cast shadows of the same kind. Okay? But that will not be the case if there is a curvature to the surface. Now, in this article, I have explained how we can do that simple demonstration in the classroom and convince ourselves that if the surface is flat, the shadows will be of the same length, and if the surface is curved, the shadows will be of different length. So maybe the listeners can go through that. So the circumference of the Earth also, Eratosthenes calculated based on this observation of the length of the shadow on a given particular day. I think he did this experiment on the day of summer solstice, around June 21st, for two different places. One is Syene and the other is Alexandria, which are two places which are separated by around 800 kilometers. And he arrived at a number for the circumference of the Earth, which is roughly 40,000 kilometers, which is very close to the actual value of about 40,700 or something like that kilometers. So it's very close by. And incidentally, I should also mention that Aryabhatta had also given an estimate for the circumference of the Earth which is fairly close to the present current estimates for the circumference of the Earth, except that there are some uncertainties or some ambiguities on how to properly interpret the numbers that Aryabhatta has given in his text Aryabhatiyam. Yeah. Right, so that's the answer.
आपने एक बात कही अभी फ्लैट अर्थ को लेके भी, है ना, मतलब हम जानते हैं कि फ्लैट अर्थ को लेके पहले से लोगों की धारणा रही है, लेकिन मैं जब इंटरनेट पे भी पढ़ता हूँ, अभी भी फ्लैट अर्थर करके कुछ लोगों की कम्युनिटी एक्टिव रहती है। हमारे एक पाठक है, उन्होंने भी एक सवाल पूछा है कि ये इसको लेके जैसे फ्लैट अर्थ को लेके किस तरीके के आर्ग्यूमेंट्स होते हैं हमारे, मतलब उनके जो फ्लैट अर्थ के बिलीवर्स होते हैं। जैसे आपने अर्थ जो है वो स्फेरिकल है, उसके आपने कुछ वो बताया कि ऐसा क्यों है, अर्थ स्फेरिकल है इसीलिए ये चीजें हो रही है। लेकिन फ्लैट अर्थ को जो मानते हैं उनका क्या आधार होता है?
Yeah, I mean, I don't really know on what basis they are arguing even now, because there is a mountain of evidence which suggests that Earth is not flat. So I think they are just overlooking all these evidences and they are just sticking on to some old idea as a dogma. They are just holding on to it. So I don't think there are any convincing reasons that they give on why they believe that the Earth is still flat. Okay, so probably an internet search will tell what are their arguments. In whatever their arguments are, we clearly know that it can be disproved. I mean, there's a whole lot of evidence in favor of that. So. Yeah, so these conspiracy theories, conspiracy ideas, they are always there. Sometimes people come up with these things and make a lot of noise about it just to grab attention, if not anything else. So I don't know whether we should take them seriously. But yeah, that's a good question. I should also look at what kind of arguments are they still holding on to. Okay. So, by the way, regarding this previous question, I just wanted to ask you, I think you had also, Amol, written an article about this Eratosthenes experiment, right, in one of the previous editions of I Wonder. And I think you have tried this in a teacher workshop also. So can you share your experience of how that experiment went and whether that particular toy model demonstration was really useful to communicate what you were trying to communicate?
तो आनंद, हम लोगों ने जब ये एक्सपेरिमेंट किया था, हमने लगभग 4 कार्यशालाओं में टीचर्स वर्कशॉप में इसको किया था। हालांकि इसको करने का जो बेस्ट टाइम है वो तो जब सन जो है वो इक्वेटर पे होता है तब आप इसको कर सकते हैं ना। मतलब आपको ये पता होता है कि सन जब इक्वेटर पे है, ये 2 दिन होते हैं, विंटर सोल्स्टाइस और समर सोल्स्टाइस। तो इन 2 दिनों में कर सकते हैं, क्योंकि वहाँ पर जिस स्टिक की शैडो है वो जब सन जो है जब हाईएस्ट पॉइंट पे होगा स्काई में तो वो 0 होगी, और फिर आपको वो कैलकुलेट करने में आसानी होती है कि आपकी लोकेशन इक्वेटर से कितनी किलोमीटर दूर है, और फिर आप उसका इस्तेमाल, मतलब उस आर्क का इस्तेमाल कर सकते हैं कि अर्थ की पूरी सरकमफेरेंस कितनी है वो निकालने के लिए। हालांकि हमारे जो एक्सपेरिमेंट था वो थोड़ा ये था कि कैसे इन चीज़ों को एक्सप्लोर कर सकते हैं हम, मतलब कुछ मटेरियल के साथ। जैसे इराटोस्थेनीस में इन्होंने भी कोई ऐसे इक्विपमेंट इस्तेमाल नहीं किए थे जो बहुत ज़्यादा टेक्नोलॉजी उसमें इस्तेमाल किया है। सिर्फ 2 खंभों की पड़ने वाली शैडो को उन्होंने उसी दिन ऑब्जर्व किया था, एक दिन अलेक्जेंड्रिया में और एक दिन साइन में। तो और एक सिंपल मैथमेटिक्स का यूज करके उन्होंने ये सरकमफरेंस निकाली थी। तो यही प्रयास था हमारा कि क्या इस तरीके के एक्सपेरिमेंट्स हम भी कर सकते हैं क्या, मतलब आज भी कर सकते हैं क्या। लेकिन इसमें अलग अलग एक्सपीरियंस ऐसे रहते हैं ना कि सबसे पहले तो स्टिक कैसी हो, कैसे उसको जमीन में खड़ा करना है, और उसकी शैडो कैसे मेजर करनी है। फिर आपको टाइम पे ध्यान रखना है कि भाई सन कब आपके हाईएस्ट पॉइंट पे आएगा स्काई में। तो एक तो टाइम कीपिंग, और उसकी बनने वाली लेंथ, और वो जो एंगल है। तो ये बोलने में जितना आसान लगता है, जब करते हैं तब उसकी डिफिकल्टी समझ में आती है कि भाई अच्छा ये बोलने में आसान है लेकिन करने में बहुत सारी त्रुटियां रहती है। तो हम लगभग 5-6 ग्रुप बना के काम कर रहे थे। तो कुछ ग्रुप ने इसको कर लिया, कुछ ग्रुप नहीं कर पाए। तो जब ये गलतियां भी जो होती है ना, जो एरर्स होती है, उसको भी हम लोगों ने डिस्कस किया कि भाई क्यों नहीं कर पाए। तो वहां पर भी काफी चर्चा हुई कि हम एंगल नहीं मेजर कर पाए ठीक से, हम वो शैडो की लेंथ भी नहीं मेजर कर पाए। तो इस तरह की जो चर्चाएं होती है ना, मुझे लगता है कि हम सिर्फ ये एक्सपोजर टीचर्स को देना चाह रहे थे कि इस तरीके के एक्सपेरिमेंट हम ग्रुप में कैसे कर सकते हैं और उसके ऊपर बातचीत कैसे हो। हालांकि रिजल्ट सही आए या गलत, थोड़ा साइंस टीचिंग में इसके ऊपर ज्यादा जोर देने की बजाय उसके ऊपर बातचीत करना कितना जरूरी है, हम लोग वो चाह रहे थे। लगभग जिन ग्रुप्स ने ये सही मतलब मेजरमेंट करी, उनके जो कैलकुलेशन थे वो लगभग सही आए, मतलब एक्यूरेट तो नहीं आए लेकिन लगभग सही आए। तो उन ग्रुप्स में ये था सेंस ऑफ अचीवमेंट कि हाँ हम ये कर पाए, और जो लोग नहीं कर पाए उन्होंने वापस से उसको ट्राई किया दूसरे दिन। तो वहां पे उन्होंने जो पिछली गलतियां की थी वो उन्होंने सुधारी। तो ये जो पूरा एक्सपेरिमेंट था, एक तो उस उन चीजों को विजुअलाइज करना कि इसको कैसे किया जा सकता है, इसको करने के लिए आपको कौन सी तैयारियां चाहिए। और जब बच्चों के साथ करेंगे, हालांकि ये कोई मैथमेटिक्स इतना भी बड़ा नहीं जो बच्चों के साथ नहीं कर सकते, मिडिल स्कूल के किया जा सकता है, लेकिन उसके लिए एक तैयारी, उसके लिए एक प्रिपरेशन, और जो तौर तरीके हैं साइंस में काम करने के, उसके ऊपर क्या क्या ध्यान देना है, उसको लेके हम लोगों ने बातचीत करी थी। और वही एक्सपेरिमेंट करके वो आर्टिकल जो है वो थोड़ा सा लगा कि इसको लिखा जा सकता है। ये साइंस की जो टीचिंग की प्रोसेसेस होती है उसको कहाँ के ध्यान रख सकते हैं। दूसरी एक बात मैं एक बस ऐड करना चाहूंगा इसमें कि एक तो हिस्ट्री को लेके भी जो बातचीत होती है साइंस की क्लास में, वो ज्यादा नहीं होती है। जबकि हिस्ट्री जो है, हिस्ट्री ऑफ साइंस, जो हिस्ट्री है उससे थोड़ी सी अलग होती है। जैसे कि साइंस की जो हिस्ट्री होती है वो कंसेप्ट के जो अ, अ, बोल सकते हैं कि जो प्रोग्रेशन हुआ है, एवोल्यूशन हुआ है उन कंसेप्ट्स का, उसको लेके ज्यादा बात करती है कि भाई कौन सी चीजें हम लोग सोचते थे। जैसे आपने कहा कि फ्लैट अर्थ हम लोग सोचते थे, लेकिन कुछ एविडेंसेस हमको ऐसे मिले, जो कि आपने आर्यभट्ट का और एरोटोस्थेनिस का भी एग्जांपल दिया, कि हमने उसको हम लोगों ने डिस्कार्ड कर दिया। तो हिस्ट्री ऑफ साइंस में ये भी होता है कि भाई आप उन चीजों को डिस्कार्ड करते हैं जो कि आपको कुछ नए तथ्य या फैक्ट मिलते हैं, तो आप पुरानी चीजों को भी डिस्कार्ड करते हैं। तो साइंस में नई चीजें या नए फैक्ट्स को एक्सेप्ट करने की एक क्षमता होती है और काबिलियत होती है। तो उन फैक्ट्स को कैसे जाने समझे, इसको लेके बातचीत का जो स्कोप होता है ना, वो नहीं होता है। तो इस तरीके के कुछ छोटे प्रोजेक्ट्स जो है वो करके बच्चों के साथ, स्टूडेंट्स के साथ इसको लेके, इन चीज़ों को लेके अप्रिशिएट किया जा सकता है। तो ये हम लोगों ने उसमें सोचा था, ये इराटोस्थेनिस का जो एक्सपेरिमेंट था, धरती की जो परिधि है उसको नापना।
So yeah, that's very interesting, because I think this sometimes, when we do an experiment, if the experiment is not properly done, then it can often lead to incorrect conclusions. So as you were rightly saying, initially, there was a lot of struggle controlling all the variables in that experiment. So inaccurate measurements or not properly set up experimental setups can actually lead to faulty conclusions. So that is also, experiments by themselves are not a foolproof way to arrive at the truth. So that's very important. And also this the discussion debate about the validity of new information, right? So a debate and scrutiny is very much part of the process. In fact, when Aryabhatta had first proposed that the Earth is not flat and it is spinning, this is not something that everyone just accepted. In fact, Brahmagupta, who came after Aryabhatta, who actually looked up to Aryabhatta for many of the ideas, was a strong critique of this one particular idea that Aryabhatta had put forth. So he strongly criticized it, and he gave several examples on why Earth is not spinning, why Earth is stationary. For example, he said that if you drop a stone from the top of a huge tower, if the Earth is spinning, then from the time you drop the stone, from the time it arrives, that stone is going to drop somewhere else, not at the basement of that tower, because the Earth is spinning. Or a bird that is flying towards the nest may sometimes never reach the nest because the nest is always flying away from the bird because the Earth is spinning. So without realizing the fact that a stone that is being dropped or the bird that is flying is also being pulled by gravity along with the spin of the Earth. So the frame of reference concept was not there then. So new ideas, even if they are true, they are not immediately accepted, and there's a lot of debate and scrutiny that goes behind it. So that's also part of the process. So discussions are important in that sense. Yeah.
तो ये सही बात है कि एक आइडिया जब नहीं आती है तो उसको लेके भी कई सारे डिबेट साइंस में होते हैं, और इसको लेके जो कह सकते हैं कि स्पिरिट ऑफ साइंस जो है, सवाल करना, ये जिंदा रहता है. आपने लेकिन अभी एक और बता दिया कि फैक्ट मतलब फ्लैट अर्थ के बिलीवर जो है शायद ये भी मानते हैं, जो आपने कहा कि अगर हम एक जगह पे जंप करेंगे तो हम लोग दूसरी जगह पे क्यों लैंड नहीं करते. हाँ, लेकिन ये सवाल आता है आनंद की यूजुअली बच्चे भी ये पूछते हैं कि भाई ये जो एक्सपीरियंस है ना, धरती घूमती कैसे है, मतलब घूमती क्यों है, तो अगर हम जंप करेंगे तो उस जगह पे क्यों नहीं, दूसरी जगह पे क्यों नहीं लैंड करते, उसी जगह पे ही तो करते. तो इसीलिए धरती घूमती नहीं, स्टेशनरी है. तो हालांकि आपने आपके आर्टिकल में थोड़ा इसको लेके थ्रेड्स भी छोड़े कि हम सोचे थोड़ा इसको लेके कि
that's not an easy concept. That is where the frame of reference comes in. So which is a slightly more evolved concept in physics. So when you have a stone that is being dropped, or when you are jumping from the floor, you are still being pulled by Earth's gravity along with the rest of the things. You are not detaching yourself from Earth. Okay? You are still very much part of the Earth, and you are being carried in that motion. So maybe one way in which we can explain this in the class is that, suppose you have a bus that is traveling and we are sitting inside the bus. We keep jumping up and down. We are still moving forward even though we are jumping up and down. That is because we are being carried by the bus. We are within the frame of reference of the bus. Now, in the case of the bus, if we jump really high, which may not be possible, we may land a little bit behind than from where we started. So we have to not confuse there, but we have to say that, even if we detach ourselves from the bus, doesn't mean that we are going to exit the bus. We are still part of the system, so we are being dragged along it. In the same way, I think we are still being dragged along by the gravity of the Earth. So, which is why a stone that is dropped from the top of a tower, or a bird that is flying, or even if we jump, we are still going to land where we are supposed to land. Okay, so things that are flying or things that are stationary, they remain where they are because they are all being pulled by Earth's gravity.
सही बात है. इसमें आनंद, अभी हमारे जो ऑडियंस है उनसे एक सवाल भी आया है, तो मैं वो सवाल थोड़ा आपके लिए पढ़ देता हूँ. इन्होंने कहा है कि आई वॉज थिंकिंग अबाउट दिस जस्ट द अनदर डे टेकिंग अ वॉक. नो मेजरमेंट आर इवन नीडेड. जस्ट वॉच अ सनराइज ऑन द होराइजन. द सन विल डिसअपियर, yet there is still light shining in the sky. तो
So yeah, so that actually is not exactly evidence against flat Earth. The reason why we still see light, for example, right now, at least where I live, it is almost sunset, and but there is the sky is still bright, and that is because the light from the sun is getting scattered off the atmosphere. So Earth is surrounded by an atmosphere, and so when the light from the sun, as it passes through empty space, and finally when it enters the Earth's atmosphere, two things happen. One is the light gets bent because it is moving from one medium, which is vacuum, which is the space between planets, to another medium, which is air, which is what surrounds the Earth. So whenever light moves from one medium to another, there is something called bending of light that happens. It's called refraction. And the other is that Earth's atmosphere is made of fine particles, dust particles, molecules, etc., which scatter some of the sunlight. So that scattered sunlight is what is lighting up the sky. Now, as the sun dips further down, this phenomenon will vanish and we will have a dark sky. So, this particular experience that this person is sharing, which is seeing a shining sky, light that is shining in the sky even after sunrise or sunset, that is because of the scattering of light, and not, we cannot really use that as an example for the fact that Earth is not flat. But in the article we give another example related to sunset, which is that if suppose you are out in the open, let's say at a beach, now you have to be close to a place where there is beach, or in a place like Rajasthan where you have nearly unobstructed view of the horizon, we may see the sun setting. So we will see the sun completely going down. Now, if we just climb to a higher location, immediately we will find that we can still see a little bit of the sun. So our viewing angle shows that there is a curvature at the horizon, and it's not really flat. Another way to do that is, if you are a slightly tall person, then around sunset you can lie down and look at the sunset, and when the sun goes out of your vision, you can just stand up and see, you'll be able to see a little bit of the crescent of the sun if you are sufficiently tall. So one can do these kind of experiment, which suggests that there is a curvature there and it's not like a flat drop at that location. So yeah. That's my answer to that question.
तो आपने आपके आर्टिकल में भी इसको लेके लिखा है कि भाई क्या मतलब एक सतह पर से किया गया सनसेट का ऑब्जर्वेशन और एक हाइट से किया गया सनसेट का ऑब्जर्वेशन, उसके टाइम में थोड़ा डिफरेंस हमें दिखाई देगा। ज़्यादा ऊपर से किया गया, ज़्यादा हाइट से किया गया वो ऑब्जर्वेशन जो है, वहाँ पे आप सन को थोड़ा ज़्यादा देर तक होराइजन पे देख सकते हैं।
Yeah, after it has disappeared from the view from ground. So it's difficult to do that experiment because it's very difficult to climb to a very high spot immediately after looking at it from ground, which is why sometimes this lying down and standing up can give us a slightly better sense of things. Yeah.
तो एक और सवाल जो है ना, हमारे जो दर्शक है अभी जो देख रहे हैं, हमें सुन रहे हैं, उनसे आया है। इन्होंने हिंदी में एक सवाल पूछा है, मैं इसको थोड़ा अंग्रेजी में करके बताता हूँ। एक जानकारी को परखने के लिए दूसरी बिना परखी जानकारी का उपयोग करना क्या सही होगा? Would it be right to use untested information to test other information? I think he is asking about जो हिस्ट्री के जो रेफरेंसेस हम लोगों ने दिए हैं, शायद उसमें वो शायद समझना चाह रहे हैं।
So that's a great question, Mukesh ji. See, that's where I said that science often works using these three approaches. One is pratyaksha, the other is anumana, which is inference. Pratyaksha is what is directly evident to us. So in modern terms, we can say the experiments that we conduct, the observations that we do, that is what pratyaksha is. Anumana is inference, what we make out of the results of those experiments. How do we interpret those observations or the results from those experiments? And often those interpretations are to some extent influenced by what is already known to be true or partially true, which is the agama or the known principles. So we rely on existing information to shed light on new things. That's the common way in which things proceed. The only thing is that what we consider as accepted knowledge has also gone through rigorous scrutiny. So we are not going to accept, in order to interpret something, we are not going to accept that is known because somebody has experienced it. It is accepted as a knowledge because it has stood the test of time. It qualifies all the factors that are essential for it to be called as a scientific knowledge, which means that it should be testable by many people, it should be falsifiable, and all these typical things. And so that becomes the body of knowledge which we refer to as scientific body of knowledge. And that scientific body of knowledge we always rely on. Now, to your question on whether it is right or wrong, sometimes that's the only way to advance forward. Right? I mean, if you have come across a new thing, then instead of reinventing the wheel all the way from the beginning, what you do is you try to see the results of your new experiment in the light of what we already know. Okay, that is why that is how you advance. That is how you move forward. So as long as what you consider as pramana or what you consider as agama, as long as that is also scientific knowledge, then I don't think there is any problem. Yeah, but that's a great question. Thank you, Mukesh ji, for that.
तो आनंद, जो हम थोड़ी देर पहले बात कर रहे थे, आपने आर्यभट्ट के बारे में भी कुछ बताया कि उन्होंने जो अपने टेक्स्ट में लिखा है, आपने आपके आर्टिकल में भी ये लिखा है कि भाई उस समय के जो उनके मेजरमेंट्स है, उनके जो यूनिट है, उसको अब के जो यूनिट्स है उसमें उनके साथ कंपेयर करना थोड़ा मुश्किल है। उसके कुछ रीजन भी आपने बताया कि शायद उतना एक्सप्लेनेशन उनके टेक्स्ट में नहीं है, लेकिन ये साइंस में जो स्टैंडर्ड यूनिट्स है उसको लेकर जो जरूरत होती है या उसको जो उसकी जो एक उपयोगिता होती है उसको कैसे हम देख सकते हैं? मतलब इराटोस्थेनिस ने भी अलग यूनिट्स में इसको नापा था। आजकल हम माइल्स और किलोमीटर यूज करते हैं, उन्होंने कुछ अलग इस्तेमाल किए थे, स्टेडिया। तो इसको कैसे देखते हैं बच्चों के साथ? इसका अगर हम काम देखें कि मैथमेटिक्स के टीचर भी और साइंस के टीचर भी थोड़ा स्ट्रगल करते हैं इन चीजों को लेकर, तो कैसे इन चीजों को देखना चाहिए हमको?
So that's a great question. So let me just explain what I wrote in that article about Aryabhata's calculation of the circumference of the Earth. So in Aryabhatiam, he gives the circumference of the Earth as 4,967 yojanas. Now the difficulty is what is one yojana equal to? Okay, and different texts and different interpretations provide slightly varying estimates. With some sources suggesting that one yojana is around 8 kilometers, some others suggest that it is something that's close to 10 kilometers. That means something like 5 to 6.5 miles. So the exact value depends on the historical context and the specific definitions used by different scholars or different texts. So when Aryabhata gives the circumference of the Earth as 4,967 yojanas, if we take one yojana as 8 kilometers or 5 miles, then that gives the circumference of the Earth as around 40,000 kilometers, okay, which is an excellent approximation to the currently accepted value. And this yojana is a unit that was used in India. It's an ancient Indian unit of distance. But the only problem is the length of how much is one yojana in modern notations. That is still a topic of debate. As I mentioned, it can be anywhere from 7 to 15 kilometers or so. 7 to 10 to 15 kilometers or so. So depending on that, the final answer would vary. And that's why there is some confusion on whether Aryabhata has arrived at the right number or not. But what is known is that he did arrive at an estimate of the circumference of the Earth. And if you accept the most accepted value for what one yojana is, which is about 8 kilometers, then you get a value for the circumference of the Earth, which is remarkably similar to what Eratosthenes had estimated, which is about 40,000 kilometers. So in that sense, Aryabhatta has made a remarkable discovery. Now, coming to the use of standard units. See, now when we start studying science, we tend to follow a certain metric system of units. If you want to talk about distance, we use meters or kilometers. We don't use yard, for example, or we don't use yojana. If you want to talk about weight, we usually go with grams or kilograms. We don't necessarily go with pounds. And so, or with any of the regional local units. In India, in different parts, we have our own way of measuring weight, measuring distances, length, etc. But in physics, in science, we go with standard units because that's one way to ensure that measurements are consistent and uniform across different contexts and regions. And this consistency is very, very important because science is not confined to one particular region. Science is a human effort, it's a global effort. So whatever you are putting out as scientific information in terms of numbers, in terms of figures, those figures are going to be used by other people in other parts of the world also. So if you want to accurately communicate information from one place to another, in terms of scientific information, I'm saying, or if you want to compare data, it's much more easier if everything is put in the same standard units. It helps a lot, for example, when you're doing trade or when you're doing design or when you're doing engineering, it's good to follow the same convention. Which is why many of the industries are now governed by regulations that require the use of standard units. These ISO units, so that is now standard. So goods and products that are manufactured by industries, they have to comply with these standards for legal and regulatory purposes, and that is because otherwise it leads to a whole sort of confusion. Even now there is confusion because in the US they do not follow this SI units or this metric system, and they follow the CGS system sometimes, and that leads to all kinds of confusion. So to avoid that, to be consistent and uniform across different contexts, these standard units are enforced. And so when we teach students in class about this, I think this idea also has to be conveyed. Why it is important to, first of all, why it is important to write the units when we write numbers. If the number has a unit, why it's important to write it. And second is why it is important to follow the standard convention. So, yeah, so that's what.
ये जैसे हम लोग थोड़ी देर पहले बात कर रहे थे आनंद कि क्लासरूम की अगर हम बात करें तो जो धरती का आकार है, शेप है, उसको लेके डायरेक्टली आइडिया जो है टेक्स्ट बुक में साइंस की, ज्योग्राफी की इंट्रोड्यूस करी जाती हैं। तो आपकी भी बातचीत में आया कि इस तरीके के सवाल ज़्यादातर बच्चों से आते नहीं हैं, लेकिन हम लोग जब बात कर रहे थे तो कुछ अल्टरनेट कंसेप्ट के भी हम लोगों ने शुरुआत में बात करी थी कि बच्चे ग्लोब को देखते तो क्या सोचते हैं, है ना। एक काफी इंटरेस्टिंग एक सवाल जो है वो आया है, दीपक चंद्रा जो है, शायद उनके भी बच्चों के साथ इस तरीके के अनुभव रहे हैं कि भाई जब हम ये कहते हैं कि अर्थ जो है वो राउंड है तो हम लोग कैसे इसके ऊपर खड़े रहते हैं, हम फिसल क्यों नहीं जाते। तो इस तरीके के सवालों को कैसे क्लासरूम में एड्रेस हम कर सकते हैं, या ये भी एक कन्वर्सेशन कैसे शुरू कर सकते हैं इस पे।
Right, yeah, that's a very interesting question. So this Deepak ji, thanks for that question. So this idea of this fisalna, this slipping, that has to do with the property of the surface on which we are standing. I mean, there are surfaces on Earth where you stand, you are going to slip. Right? I mean, if you stand on a ice surface that is covered with ice, then you are going to slip. Or if there is oil that is spilled on a surface, if you step on that surface, you are going to slip and fall. So in that sense, whether we will slip and fall, it depends on the property of the surface. Now, if what Deepak ji means by why we don't slip is like why we don't fall off the earth completely, then that has to be explained with the help of this property called gravity. Okay, so that's a nice place to bring in discussion on gravity. There, I think you have to tell that objects are held by this unseen hand that every object that has mass can exert on another object, which is this gravitational force, which is a pull force. And there, I think the common misconception that people have is if you take Earth as a sphere, we assume that gravity is acting downwards, which is why we are kept on hold on the surface of the Earth. And if you jump, we still come back to Earth because gravity is pulling us down. So then sometimes children ask, so what, if the Earth is a sphere, if Earth is not flat, then what about people who are on the other side of the sphere? For them, down is into space. So won't they just fall off? Okay, so that's a common misconception. In fact, one can pose this as an open-ended question also when we are discussing about the shape of the Earth in the classroom. We can ask the children themselves that if gravity is what is holding us downwards, then what about people on the other hemisphere of the Earth? Won't they just fall down because down is away from the Earth for them? So there, I think it's a good place to bring in this discussion on gravity and maybe clear some misconceptions about gravity itself, because down in that sense is very relative. Down always points towards the center of the Earth, no matter where you are. So when you are on the other side or the underside of the Earth, you are still standing upright because gravity is pulling you towards the center of the Earth. So, for example, like places in Australia or places like Australia or the South Pole, people who are living there aren't upside down. They are not at the risk of falling off. For them, down, just like everyone else, is towards the center of the Earth. And that's how gravity works. And gravity works the same everywhere. And we know that a sphere doesn't have any edge. So for everyone, center means towards the center of the Earth itself. So yeah, so that's the way. So that's a good way to actually clear some confusion, as I mentioned, about gravity also, because this confusion exists when people discuss gravity, because gravity always acts downwards. That is the statement that's given. Now, obviously, people will think people who are standing down, for them down means away from the Earth. So yeah.
एक और हाँ आनंद कुछ कह रहे हैं?
No, I was not saying anything. Sorry.
अच्छा, तो एक और काफी इंटरेस्टिंग सा सवाल बच्चों से आता है जो टीचर कहते हैं. मेरी शिक्षक से बात हो रही थी तो उन्होंने कहा कि 5वीं क्लास में तो सोलर सिस्टम बताई गई है, तो ये सोलर सिस्टम में सभी ग्रह जो गोल ही दिखाते हैं, मतलब एक पिक्चर आता है, तो वहां पे उन बच्चों का सवाल आता है कि ये गोल ही क्यों है, ये ट्रायंगल क्यों नहीं है, ये सिलेंड्रिकल क्यों नहीं है, ये कोन क्यों नहीं है. तो वहां पे जब बच्चों से बात करेंगे तो मतलब किस चीज का ध्यान रखा जा सकता है कि भाई दूसरा शेप क्यों नहीं, सिर्फ गोल ही क्यों?
That's a very interesting question. So I don't know whether in very lower classes, lower grades, whether an adequate explanation can be given. Maybe I also need to think about what are some of the simple everyday examples that we can use to convey the underlying principle. But the underlying principle is this: any system that is bound by its own gravity, it's going to assume the shape of a sphere. Okay. So if you think of Earth or any of the planets, as they mentioned, the solar system, everything else is also a sphere. If you think of these planets as made of small building blocks, then each of those building blocks is going to attract every other building block through this force of gravity. So they are all pulling each other together. And so when they are pulling each other together, they are coming closer and they will like to form a single entity. Now that is called a self-gravitating system, a system that is held by its own gravity. And when you have a self-gravitating system, the smallest shape that it can assume, or in other words, the shape that it can assume which occupies the least volume, is that of a sphere. And which is why the self-gravitating systems like planets, stars, etc., they all are in the form of a sphere. Now, technically, if the self-gravitating system is influenced by any other forces, for example, if the system is spinning rapidly, then there is something called centrifugal force, which is a force that pushes things away, is also acting. So that can slightly deform the shape of that object. So for example, if you take the case of Earth, we know that Earth is spinning and it is spinning at a certain rate. And because of that spin, Earth is not a perfect sphere. That spin creates a centrifugal force which opposes this self-gravity that is trying to pull things closer together. And for that reason, even though very loosely we say that Earth is not flat, Earth is a sphere, Earth is also not a sphere, it is of some other shape. It's called an oblate spheroid, which is also mentioned in the article in a very passing way. Oblate spheroid, and most of the globes that we get to buy from shops, they don't really show this. Some of them show it, but some of them don't show it, and that is because the deviation from a perfect sphere in the case of Earth is very, very small. Okay, so it's probably not even worth showing. But if you want to be very accurate about the description of the Earth, then because of the centrifugal force, Earth and many other planets, they are not perfect spheres, they are oblate spheroids. So how to explain why these things are spherical for primary school or maybe middle school students, I will also have to think about it. Maybe that's a nice theme for one of the articles for the upcoming edition. What are some of the everyday examples or experiments that we can do which shows that self-gravitating systems will automatically assume a spherical shape? It's a great question. Yeah.
आनंद, जैसे आपके आर्टिकल में भी आपने कुछ चीज़ों के बारे में कहा है कि फ्लैट और राउंड को कैसे देखा जाए, है ना? तो आपने कुछ बॉक्स में एक एग्जांपल भी यूज़ किया है कि क्यों हमें ये फ्लैट दिखती है राउंड चीज़ भी, है ना? तो थोड़ा उसके बारे में बताएंगे, क्योंकि अगर हम ये कहते हैं कि भाई अर्थ राउंड है, तो उसके लिए कुछ और भी चीजें समझने की जरूरत होगी कि भाई क्यों हम हमारे व्यू में वो कर्व नहीं देख पा रहे या वो राउंडनेस नहीं देख पा रहे.
Correct. Yeah, so the reason why we are not able to perceive the curvature of the Earth so easily, reason why it looks flat, is because of the size of the Earth and our own small size compared to the size of the Earth. So in the article, given an example of an ant that is walking on a huge ball, like you can think of a football or a basketball. You imagine that there is an ant that is walking on the surface of that ball. Now, if you look at the basketball from the point of view of that ant that is walking on the surface of that ball, that small insect, the basketball is really large compared to the size of the ant. So whichever direction the ant looks, for the ant, the surface is going to look more or less flat because the curvature is not very strong. It is a slow curvature. And so only if you think of an object that has a size and shape similar to yours, we will be able to perceive it. For example, when we look at the basketball, when we look at it, we can easily see that it's a curved ball, it's a spherical ball. That is because our size is much larger compared to that of the basketball. So we are living on an Earth which is enormously large compared to ourselves. So up to the extent that we can see all the way to the horizon, it looks flat because the way Earth curves is so slow that the curvature we don't experience it. It's very similar to the ant that is walking on a basketball. The ant can keep on walking. Suppose the ant is walking on that basketball, it can keep on walking. It may think that it is walking on a flat surface, but eventually it will return to where it started without ever falling off the edge. Okay, so this can perhaps help children visualize the concept on a smaller scale. How scale plays a very important role. Maybe another example is, suppose you are driving in a circular track. Suppose you are riding a cycle or a scooter or a car in a circular track. You are going round and round in circles, much like how you would keep walking around the earth, right? So if the track is really wide, then there are times when you feel like you're just going straight. But if you keep on going like that, you are going to eventually end up where you started. Okay? So maybe these kind of examples might help children visualize that. But if the track is actually very small and compact, you will immediately feel that you are moving on a curved track. But if the track is really large, then there are times when we are actually moving straight. Okay? We may feel like we are moving straight because the track is bending very slowly. And that's exactly what is happening. So some of these metaphors can be used to maybe communicate why we also feel the same when we stand on the surface of the earth.
हाँ, कभी के बच्चों ने ये सुना नहीं कि कोई धरती के छोर से गिर गया.
Right.
तो बच्चों के साथ थोड़ा सा इस चीज को लेके भी और भी क्या एविडेंसेस हम लोग बात कर सकते हैं कि अर्थ का जो शेप है वो राउंड है. कुछ तो चीजें आपने बताई जो सिंपल है, जो कि हम लोग मिडिल स्कूल बच्चों के साथ भी कर सकते हैं कि अलग अलग हाइट से सनसेट को देखना, इन चीजों को समझना कि भाई अर्थ का जो कर्व है वो कैसे इमेजिन किया जा सकता है. फिर इरेटोस्थेनिस का एक्सपेरिमेंट हम लोग बात कर रहे थे. और भी कुछ चीजें इसमें हो सकती है क्या जो टीचर भी अपनी क्यूरियोसिटीज को और जानने समझने के लिए एक्सप्लोर कर सकता है.
Yeah, so in the article we have presented about 4 or 5 different scenarios, 4 or 5 different experiments that can be done. Some of them does not require any setup. Some of them require very small setups like ball and stick, etc. So other than that, I cannot really think of any way in which the children can engage in an activity through which they can learn that the earth is not flat. I mean, of course, there is always this option of looking at images taken by satellites, etc. But that is not anyway, you are not directly engaging. You're just listening to some information. But other than the activities that are mentioned in the article, I cannot think upfront about any more activities that can be done. Probably there are, but I'm not able to think at this moment.
तो अभी हम लगभग 1.5 घंटा हुआ है हमें बातचीत करते हुए और काफ़ी चीज़ों पे हम लोगों ने बात करी है. आर्टिकल्स में जो पॉइंट्स आपने मेंशन किए थे उसके ऊपर भी आपने आपके विचार जो है विस्तार से बताए हैं. कुछ हमारे पाठकों ने और जो हमारे साथ जो जुड़े हुए साथी है हमारे दर्शक, उन्होंने सवाल भी पूछे. काफ़ी इंटरेस्टिंग ये बात है कि धरती का आकार कैसे समझा जाए. जो लोग अभी ये आर्टिकल नहीं पढ़े वो ये ज़रूर पढ़ सकते हैं. हमारा जो ऑनलाइन भी ये आर्टिकल्स हमारे अवेलेबल है हमारी आई वंडर के वेबसाइट पे. वहाँ पर जाके आप इन आर्टिकल्स को पढ़ भी सकते हैं. तो आनंद, हम लोग थोड़ी बात को हमारे विराम देंगे. तो आपके मन में और कोई थॉट्स इसको लेके आ रहे तो आप शेयर कर सकते हैं कि भाई धरती के आकार को या विज्ञान में इस तरीके के सवालों को कैसे देखना चाहिए एक साइंस टीचर ने.
Right. So I think, we already talked about why, even though this is a very well established fact, even though everybody knows that Earth is not flat, etc., why it's important to rediscover this in the classroom context. We already went through that process. We already discussed that, and I would say that this is also gives teachers an opportunity, gives a nice platform for teacher to talk about the impact of new ideas or new discoveries, what kind of a transformative impact it can have. For example, as I mentioned, before the time of Eratosthenes or Aryabhatta, most people thought that the earth is flat. Now, through careful observations, through very deep thinking, and they arrived at this conclusion that the Earth is not flat, and then they arrived at the actual shape of the Earth, spherical Earth. And now, further down, we now know that it's an oblate spheroid, which means it's not a perfect sphere either. It's slightly flattened at the poles and bulged at the equator. So we are adding more and more information to it. So with every new discovery, there is some transformation that it's bringing about. So the discovery of the shape of the Earth, that's also a nice opportunity for teacher to talk about what kind of an impact it has had in the way societies evolved after that point of time. The acceptance of the spherical Earth, what kind of far-reaching implications it had. Well, one of the implications that I can think of is once you realize that you're not going to fall off the edge of the Earth, then navigation becomes a much more accepted way of exploration. And if you feel that you're going to fall off the tip of the Earth, then nobody is going to really be adventurous enough to venture to that. Astronomy and many other sciences have benefited by accepting this truth that we are living on a spherical Earth. So that's again one important point. I think it underscores how scientific discoveries can transform our understanding of the world and influence various aspects of life. So even in things which now we take for granted, we can always look back and see when that idea emerged, when it was a new idea, what way did it change the course of human society, how we conducted ourselves, how we progressed from that point onwards. So I think that's also a very important point, and that's also part of, I think, the nature of scientific discourse, because ultimately whatever we discover through science is going to have implications in society. So that's another way, I think. Yeah, so that's what I feel.
तो आनंद, ये आपने बात बिल्कुल सही कही है। जिस तरीके से ये किसी कंसेप्ट की जो प्रोग्रेशन होती है, एवोल्यूशन होता है, नई बातें सामने आते हैं, नई फैक्ट सामने आते हैं, इसको जानना समझना ये एक ज़रूरी प्रोसेस है। और इसलिए भी ज़रूरी है क्योंकि साइंस का जो नेचर है, साइंस की जो प्रोसेसेस है, उसको जानने और समझने में ये मदद करता है। जो हमारे साइंस के टीचर्स हैं उनको मैं एक बात और बताना चाहूँगा कि जो बात आनंद भी कह रहे हैं, साइंस की जो करिकुलम फ्रेमवर्क है, जो अभी एनसीएफ 2023 जो अभी आया हाल में, उस डॉक्यूमेंट में भी साइंस एजुकेशन के कुछ एम्स दिए गए हैं, जिसमें से एक एम जो है ये भी है कि साइंस की जो नेचर और प्रोसेसेस है, उसका एवोल्यूशन कैसे हुआ है, उसको जानना समझना बच्चों के साथ मिलके। तो इस तरीके के जो टॉपिक्स हैं, मुझे लगता है ये काफ़ी अच्छी अपॉर्चुनिटी देते हैं क्लासरूम में बच्चों के साथ बात करने में, एंगेज होने में। तो साइंस के टीचर ज़रूर इन चीज़ों को लेकर एक्सप्लोर कर सकते हैं। आई वंडर में इस तरीके के कई सारे आर्टिकल आपको पढ़ने को मिलेंगे। जो मैंने कहा है कि आप ऑनलाइन भी इसको पढ़ सकते हैं, और इसकी प्रिंट कॉपी भी अगर आपको चाहिए तो आप सब्सक्राइब कर सकते हैं हार्ड कॉपी के लिए। ये हार्ड कॉपी जो है आप तक पहुंच जाएगी। तो ज़रूर मुझे लगता है कि आनंद, आपको भी काफ़ी मज़ा आया। मुझे तो काफ़ी मज़ा आया आपने जिस तरीके से इन चीज़ों को सिंपल तरीके से रखा है। काफ़ी सारे दर्शकों की, पाठकों की और हमारे साथ जुड़े हुए साथी जो है उनकी कमेंट्स में पढ़ रहा था, तो वो भी इस डिस्कशन को वो एंजॉय कर रहे थे। कई सारे सवाल आए हैं हमारे साथियों से जो हम लोगों ने लिए भी हैं। कुछ सवाल शायद आपसे पूछने में रह गए हो या हम नहीं ले पाए हो, तो आप उन्हें हमें मेल भी कर सकते हैं। जो मेल मैंने आपको बताया था पहले, iwonder@apu.edu.in पर हम आपके सवालों के जवाब आप तक पहुंचाने की पूरी कोशिश करेंगे। तो आनंद, थैंक यू, आप ज्वाइन हुए, और हमारे सभी साथियों को जो हमारे साथ जुड़े हैं, हमारे जो पाठक, हमारे जो दर्शक हैं, उन्हें भी मैं शुक्रिया और धन्यवाद कहना चाहता हूँ। हमारा अगला जो आई वंडर होगा वो होगा 9 अक्टूबर को। इसका समय वही रहेगा 4:30 बजे, और आप ज़रूर उस वेबिनार में भी जुड़िए। और उसकी जानकारी पाने के लिए आप आई वंडर को सब्सक्राइब कर सकते हैं, इस चैनल को, अजीम प्रेमजी यूनिवर्सिटी चैनल को इसको आप सब्सक्राइब कर सकते हैं ताकि आप तक ये अपडेट पहुंच जाए। तो शुक्रिया सभी साथियों का, आनंद का। तो हम लोग यहाँ पर हमारी बातचीत को अभी विराम देते हैं। थैंक यू।
Thank you.